All right, let's dive right in. Today, we're getting into the heart of how pretty much all software actually works. We're going to break down that journey from just raw data all the way to smart, automated decisions, and we'll unpack the basic toolkit every single programmer uses. So let's get started. Have you ever wondered about that? You close your music app, you open it back up later, and somehow it just knows that playlist you spent hours putting together. Or how about a game that remembers your top 5 high scores? How in the world does it keep track of all that information in a nice, orderly list? Well, spoiler alert, it's not magic. Behind all of these cool features is a single, really powerful concept. It's a foundational tool that programmers use to store and manage collections of data. And today, we're going to get a handle on it. Okay, so our first stop is what I like to call Java's digital filing cabinet, the array. This is, without a doubt, the first step in programming. You can't do anything interesting until you have a place to actually put your information, right? So what even is an array? Well, at its core, it's just a container, but it has two really important rules. First, you decide how big it's going to be right at the start, and that size doesn't change. Second, every single thing you put inside it has to be the same type of thing. I love this egg carton analogy. You got a specific number of slots and you're only putting eggs in them. Not eggs and oranges and tennis balls, just eggs. And what's really cool is how simple it is to bring one of these arrays to life. You just tell the computer how many slots you need, you create the container, you fill up each slot one by one, and then you can just print everything out to see what you've stored. It's a really logical, clean process. And if you're going to remember one thing, it's this one line of code right here. This is basically the magic spell. It's you telling the program, hey, I need a new digital egg carton, make it big enough to hold this many integers. That single command reserves the memory and gets your filing cabinet ready for action. And trust me, this isn't just some abstract thing you learn in a class. Arrays are literally everywhere. They're managing students' scores in a school's database. They're handling all the data coming in from a weather sensor. They're keeping track of your inventory in a video game. And yep, they are holding all the items in your online shopping cart. They're the go-to way to organize any list of similar stuff. Okay, so we've stored our data. It's all nice and tidy in its filing cabinet. That's great. But data that's just sitting there isn't very useful, is it? So let's move on to the next step. We're going to put that data to work. So imagine our array is holding 5 test scores. We can see them right there, 10, 20, 30, 40, and 50. But what if we need to know the total? We need the program to actually calculate that for us. So how does it do it? The answer is a loop. A loop is just a simple but super powerful command. It basically tells the computer, I want you to visit every single slot in this array one by one, grab the number inside, and add it to a running total. Let's actually watch this happen step by step. First, the program creates a variable. Let's call it sum, and it sets it to 0. Think of this as our empty basket ready to collect all the values. Okay, the loop starts. It goes to the very first slot, finds the number 10, and adds it to our sum. So our total is now 10. Simple enough. Then it moves to the next one. It finds the 20, adds it to our current total of 10, and now our sum is up to 30. You can probably see where this is going. The loop just keeps on chugging along. It grabs the 30, then the 40, then the 50, and it does this automatically until it's visited every single slot. And just like that, this simple, repetitive process gets us our final answer, 150. And again, this simple act of adding things up is absolutely fundamental. It's how financial software totals your expenses for the month. It's how a business calculates its quarterly sales. It's how a teacher figures out a student's total marks. This is the first crucial step in analyzing data, turning a long list of numbers into one single meaningful answer. So we've stored data and we've processed it. Now for the really exciting part, giving our program a brain. This is where we talk about control structures, the logic that lets a program actually think and make decisions on its own. You can think of your program's code as a straight road. Well, control structures are the things that add forks in that road. They let the program choose which path to take based on some condition. They also create what you can think of as assembly lines, letting the program repeat a task over and over again, super efficiently. Now, for making choices, we have 2 main tools. First, there's the if-else statement. This is your classic fork in the road. It asks a simple true or false question, like, is this number positive? If the answer is true, it goes down one path. If not, it goes down the other. Then you've got the switch statement, which is more like a menu selector. It's perfect for when you have a list of specific choices, like if the user picked option 1, do this. If they picked option 2, do that. And what about that repetition, that assembly line? That's where the for loop comes back in. We already saw it in action when we were adding up our array. It is the absolute perfect tool for when you know exactly how many times you need to do something, whether it's visiting 5 elements in an array or printing a multiplication table 10 times. So, let's bring all of this home. We've looked at 3 different concepts, but their real power, that only shows up when you see them as one single cohesive toolkit. And here they are. First, you've got arrays, that's the finding cabinet for your data. Then you've got operations, like summing. Those are the tools to turn that data into answers. And finally, you have control flow. That's the brain that uses things like if-else statements and for loops to make decisions. These 3 are the pillars of programming. Because when you put these 3 pieces together, something pretty incredible happens. You stop just writing a simple list of instructions for a computer to follow blindly. You actually start building applications that can store information, analyze it, and then make decisions based on what it finds. You're basically teaching it how to think. And that brings us to the end. You've seen the filing cabinet, the tools, and the brain. You now have the fundamental toolkit of a programmer. So the only question left is, what are you going to build first?